You're asked to expand each of the following expressions. So they're a little bit uglier than we're used to because they have a bunch of variables and also some trig functions. So I'm going to use FOIL actually instead of the box method to show this one. So I have b minus a cosine of c squared. So I'm multiplying b minus a cosine c by itself. So FOIL means I'm going to multiply these two together to get b squared first, and then outside I'm going to multiply ab cosine of c, and then inside I'm multiplying these two together, so minus ab cosine c, and then lastly I'm going to be multiplying these two together, so I got positive, what is this, a squared cosine squared of c. And now I'm just going to combine like terms because these two are the same thing. So my final answer, b squared minus 2 ab cosine of c plus a squared cosine squared of c. That's as expanded as each of these get here. I multiply them together afterwards, and that's what we get. So second one, similar idea here. I'm going to rewrite. So I have sine of d. Ooh, that's not sine of d. Sine of d minus cosine of d times itself. So another sine of d minus cosine of d. And so when I multiply these, first sine times sine is sine squared. Sine times cosine is, I'm going to call this sine of d cosine of d. Inside is going to be sine of d cosine of d again. And the last is going to be plus cosine squared d. And so the last two things here, I'm going to condense these two together because they're the same thing. And I'm going to move this one around to show you something. So I have sine squared of d plus cosine squared of d minus 2 sine d cosine d. If you left it like this is technically true, but if you remember the Pythagorean trig identity, sine squared plus cosine squared equals 1, that means that this here, no matter what d is, I am going to, those add together to get just 1. So my final simplified version of this is 1 minus 2 sine d cosine of d. And again, that's just knowing that sine squared plus cosine squared equals 1.